The objective of today's lesson is to be able to simplify algebraic expressions and to be able to identify like terms. All right, first, what do we mean by like terms? Well, parts of an algebraic expression are called terms. Like terms are terms that have the same variable raised to the same powers or exponents. Constants are also like terms. Constants are terms that do not have a variable. To identify terms and like terms in an expression, first write the expression as the sum of its terms. All right, let's take a look at our first example. We want to identify the terms. Well, our terms are parts of the expression that are separated by addition and subtraction. So I have one term, two terms, three terms, four terms in this expression because it's those four terms that are separated by the addition and subtraction signs. So I first want to list my terms. So my terms would be 9x. I also have negative 2. I also have 7. And I also have the opposite of x. Those are my terms. All right. My like terms would be the terms with the same variable to the same power. So my like terms would be the 9x and the opposite of x, right? Those are like terms, right? And my other pair of like terms would be the negative 2 and the 7, all right? Our second example, what are the terms? I have 1, 2, 3, 4 terms in that expression, right? So my terms are z squared, 5z, negative 3, z squared, and positive 1z. My like terms are the terms with the same variable to the same power. So my like terms would be the z squared and the negative 3z squared. And my other pair of like terms would actually be 5z and the positive 1z. All right? We want to also be able to simplify an algebraic expression. An algebraic expression is in simplest form when it has no like terms and no parentheses. To combine like terms that have the same variables, use the distributive property to add or subtract their coefficients. All right? Let's take a look at this next example. Right? To simplify this expression, we have to identify the like terms. Well, my like terms have the same variable to the same power. So I have 3/4 y and negative 1/2 y. Well, negative 1/2 y is the same as 2/4 y, right? So that's the same as 2/4. So I have 3/4 plus negative 2/4. It's going to give me 1/4 y. And then we have positive 12 and negative 6. Positive 12 and negative 6. It's going to be positive 6. So my simplified expression would be 1/4 y plus 6. Once again, an expression is in simplest form when we have no parentheses and no like terms. All right? So let's try some of these problems on our own. All right? Let's try problem number 1. All right? I want to identify the terms and the like terms. So for problem 1, what are my terms? Well, my terms are separated by addition and subtraction. So we have 3 terms in that expression. Your terms are y, 10, and negative 3/2 y. Your like terms are going to be the y and the negative 3/2 y because those terms share the same variable to the same power. Let's try problem 2. We have 1, 2, 3, 4 terms in the expression. So your terms are 2r squared. We have 7r. We have the opposite of r squared, and we have negative 9. Your like terms are your terms with the same variable to the same power. So my like terms would be the 2r squared and the negative 1r squared. And that would be it because the r and the 9 are not like terms. So we only have a pair of like terms there for problem 2. Problem 3, we have, let's see, I want to be using purple there. We have 1, 2, 3, 4, 5 terms in that expression. All right? And what are your like terms? Well, the like terms for problem 5, or let's start with our terms. Terms are separated by addition and subtraction, so your terms would be 7, 4p, -5, 1p, and 2q. Those are your terms. Your like terms, let's see what we have here. Like terms have to have the same variable to the same power. So we have the 4p and the 1p. They are like terms. But we also have our constants. Our constants are 7 and -5. They are also like terms. All right? Let's try problem 4. Problem 4, we want to simplify the expression. To simplify the expression, first write it. So we have 14 minus 3z plus 8 plus z, 1z. To simplify an expression, we combine the like terms. Well, my like terms are -3z plus 1z. That's going to be -2z. Then we also have 14 and +8. It's going to be 22. So my simplified expression would be -2z plus 22. And remember, an expression is in simplest form when we have no like terms and no parentheses. I have no parentheses in this expression, and my terms do not share the same variable to the same power. All right? Problem 5. Write the expression 2.5x plus 4.3x minus 5. Your like terms have the same variable to the same power, so we combine them using their coefficients, 2.5 and 4.3. That's 6.8 x's. And then we still have the -5. That's my simplified expression. I can't combine those terms because they're not like terms, so I can't put them together. And that was the importance of identifying like terms in the previous step. All right? But now we have to put those like terms together. All right, in problem 6. Problem 6, we have 3/8 b minus 3/4 b. All right, when we combine rational numbers, we have to have the common denominator. Right now we don't have a common denominator, so if I rewrite -3/4 with a common denominator, that's going to be the same as -6/8. So now I have positive 3/8, take away 6/8, it's going to be -3/8 b, and that's my simplified expression. All right, let's go to our next page. Now we want to be able to use the distributive property to simplify an expression. When we use the distributive property, we're multiplying a sum or a difference. Here we're multiplying -1/2 times the sum of 6 times the number and 4. So I take that -1/2 that's outside of the parentheses, and I have to multiply that by each of the terms in the parentheses. The opposite of 1/2 times 6n, that's -3n. The opposite of 1/2 times +4, it's going to be -2. Then I have plus 2n. My like terms are the n terms, so -3 plus +2. When I add my like terms, I use their coefficients. -3 plus 2 is -1n. I still have the -2. There's my simplified expression. All right, let's try these 3 problems down here. All right, problem number 7. First, I start with my distributive property. 3 times q is 3q. 3 times 1 is 3. Don't forget to multiply that back term. Then we still have that -4. My like terms here are my constant terms, +3 and -4. That's going to be -1. So we're left with 3q plus -1, or 3q minus 1. That's my simplified expression. Problem 8, I use the distributive property, -2 times g, -2g, so those are g's, and -2 times +4, that's going to be -8, but we still have that 7g. My like terms, the the -2g and 7g, it's going to be 5g's. And then we have -8. There's my simplified expression. All right? This next one, the 7 is not being used in the distributive property, but -4 times 3/4. We multiply, 4 times 3 is 12. 12 divided by 4 is 3, but that's -3x. And then 4 times 1 is 4. Divided by 4 is 1, but negative times negative is positive. My like terms, 7 and 1 is 8, so we have -3x plus 8, my simplified expression. All right, next page. Here we're given a word problem. Each person in a group buys a ticket, a medium drink, and a large popcorn. Write an expression in simplest form that represents the amount of money the group spends at the movies. Interpret the expression. Well, we don't know how many people are going to the movie, so that's going to be the variable x. But each person buys a ticket at $7.50. Each person buys a medium drink at $2.75. And each person gets a large popcorn at $4. The expression then, each term has an x with it. They're all like terms. So I want to add their coefficients. So we have the 7.5, the 2.75, and we're adding the 4. But remember, when we add the whole number with the decimal, right, we have to line up the decimal points. So this is 5, 7 and 5 is 12. We put down the 2, carry the 1. 1 and 7 is 8, and 2 is 10. 10 and 4 is 14. Right, so we have 14.25, but that represents the coefficient of x. So we have 14.25x. That's the simplified expression. All right. Our next problem, or next group of problems, I thought these were kind of interesting. We want to be able to represent the perimeter of the figures and write an expression to do so. So first, let's identify our x terms. Here's an x, that's 4 x's, 5 x's, and 2 x's. 2 and 5 is 7 plus 4, that's 11 x's. Then we have our y segments. 2 and 8/10 y, 2.2 y, 2 and 8/10 y, 2.2 y, that's going to be 5 y's. So there's my perimeter of that figure in terms of x and y. Let's try the next one. Now these little marks here, in case you don't remember, these are congruency marks. Congruency marks means that this segment here is the same as this segment. So if this segment can be represented by the expression 5 times a, that means that this segment as well can be represented by the expression 5 times a. And if we put our a segments together, all right, let's do that. We have 5 a's here and 3 a's here. That's 8 a's. Plus another 3, that's 11 a's. Plus another 5, that's 16 a's. Let's put our b's together. We have 6 b's plus 2 b's, so that's 8 b's. And then we have our constant, right? We have 4 for this segment here, plus 4. This is an expression in simplest form. Notice we have no like terms and we have no parentheses, and that meets the definition of the expression in simplest form. Here we have 2 congruency marks, so that means this 2h, right, is the same as this expression here, or that segment is also going to be 2h in length. We have this segment here is represented by 4j, but notice we have all these congruency marks that are the same. So this is 4 times j, right? This is 4 times j, the length of this segment. That's 4 times j. So if we put all of our j's together, that's 16 j's plus 4 h's. All right? And then the last problem I think we want to take a look at, all right? Let's circle that. All right, is this problem here? It's the other one we did with our class. Which expression doesn't belong here? When we do a problem like this, you want to simplify each expression and then find the one that doesn't belong. So if we simplify this expression here, 1x and 3x, that's 4 x's, then we have minus 2, and that matches this expression here. But if I use the distributive property here, that's 4 times x, and 4 times 2 is 8, right? That one doesn't match. But let's see if this one matches or if it doesn't match. We have positive 7, take away 3, that's going to be 4 x's, and then we have the minus 2. Right? So we see that the one that doesn't match is going to be here. All right? So what's the key? The key takeaways here, be able to identify like terms. Like terms are the same variable to the same power, or like terms can be constants. Constants are terms without the variables. Second, when we simplify algebraic expressions, we combine the like terms, combine the constants, but we write the expression with no parentheses and no like terms. Right? Hope that was helpful.